All right, guys, we're going to talk about complex numbers, numbers in the form a plus bi, also known as imaginary numbers. Let's hit it. All right, I. The number I represents the square root of -1. I is the square root of -1. What this does, it empowers us a little bit to be able to take the square root of negative numbers and do some operations that we couldn't do normally. Don't have a lot of time on this video to tell you a whole bunch of applications. There are a lot of, especially engineering applications with I, and it's very important. It's a very important number, even though it is imaginary. Or aren't all numbers imaginary, really? It's a deep discussion. All right, definition of a complex number. Complex numbers, an expression of this form, a plus bi, has two parts. Oh, by the way, if I is a square root of -1, this is a big deal right here. I squared is -1. I squared is -1. The real part is the a. The imaginary part is the b. And also, two complex numbers are equal if and only if their equal parts are, the real parts are equal and their imaginary parts are equal. All right, just some operations here. The first one, addition. When you add, you just add the real parts. So I do 3 plus 4 is 7. And you add the imaginary parts, which will give me positive 3i. That's all you do. Do not add the real with the imaginary part. Subtraction works the same way. Subtract the real parts, 3 minus 4. Subtract the imaginary parts, 5 minus -2i is really 7i. That's all you do. Part C, you can do FOIL with complex numbers, but watch this. It's going to take an extra step here. If I do first, outer, inner, and last, what happens, that's a normal FOIL looking deal right there, except for this right here, that I squared. The I squared, remember, is really -1, which changes that -10 to a positive 10. So I'm going to take that positive 10 now, add it to that 12. I'm going to add my two i's, which is 14i, and that's it. So a little bit of an extra step there because of the I squared. Never leave an I with an exponent in your final answer. Part D, I to the 23rd. A couple ways you can go through and do this one. I like doing it this way. I think you break it down everything with I squared. Remember, I squared is really -1. So if I do I squared to the 11th power, that's 22 i's. Okay, the problem obviously has 23 i's in it, so I'm going to put one more I here. I squared to the 11th power, that's really -1 to the 11th power. And because it's an odd exponent, the -1 stays negative, so it's really -1 times I, which is -I. And that's all you have to do there. All right, when you divide, I haven't done division yet, very much, you got to keep this in mind. I is the square root of -1, so technically I is a radical. And remember, we're not allowed to leave radicals in our denominator ever. So I'm going to multiply by the conjugate, just like I did when we did regular radicals without the I. So the conjugate of 1 minus 2i is 1 plus 2i. Do the numerator and denominator by that conjugate. Remember, when you multiply conjugates, you got to do first last. 1 times 1 is 1. -2i times positive 2i is -4i squared. I squared changes that -4 to positive 4, so 1 plus 4 is 5. That's your denominator. My numerator, I'm just going to do FOIL. Do first, outer, inner, and last. And there's that I squared again. Remember what I squared is? That changes the positive 10 to -10. I'm going to add that to the 3 in the front. 3 -10 is -7. And I have a 6i and a 5i. That's 11i. Okay, so that's how the division works. It's just multiplying by the conjugate. Same thing on the second one. Even though it looks a little bit different, the conjugate of 4i, remember, anytime you do conjugates, you change the sign on the radical. So the conjugate is technically, sorry about that, -4i. So I start working through that. If I multiply the bottom again, well, just -4i times positive 4i is -16i squared. Don't forget I squared is -1, which makes that -16 become positive 16. Numerator, I'm just going to distribute. -4i times 7 is -28i. And if I do -4i times 3, I get -12i squared. I squared changes the sign on the 12 to positive 12. And then you got the -28i. Now, because everything up there is even, I'm going to take a 2 out of all those numbers. If I take a 2 out of 12, it is 6. 2 out of 28 is 14. Take a 2 out of 16 is 8. Oops, I should have taken a 4 out. I don't know why I didn't do that. So I got to take a 2 out again because I forgot to take a 4 out. So it's going to be that right there. All right, not that big a deal. Okay, the main thing that an I gives me the chance to do is take the square root of a negative number. So it says if -r is negative, then the principal square root is opposite of r. Okay, so if you have a negative inside your radical, you can make it positive just by removing the I, taking the I out. That's what it meant if I is square root of -1. So what it's really saying is, let's say I have the square root of -25. I can break that down like this, like square root of -1 times the square root of positive 25. Remember, the square root of -1 is I. The square root of 25 is 5, so you get 5I. Okay, so again, that's, and you're going to hear me say a lot, well, it's negative, so I'm going to take an I out. The reason I'm taking the I out is because I'm breaking it down like this. I'm breaking it down with a -1 inside a radical and then a positive number. So let me show you one. All right, this one says evaluate this mess and express it in the form like we've been doing, like A plus B. I like the the complex form. So what I'm going to do first is I'm going to simplify all these radicals that I can. 12 is 4 times 3, so that's going to be 2 on 3. The second one, I'm going to remove the I, makes that positive. Second parentheses, again, square root of -4. Square root of 4 is 2, because it's negative, it's going to be 2I. Now I'm ready to go my forward method. So I'm doing first, which is going to be 6 on 3. I'm going outer, which are these two, which is going to be 4I on 3. I'm going inside, those two, which is -3I on 3. Then I'm going to go last, which is going to be -2I squared on 3. Okay, so there's a lot of stuff there to look at. First thing I see is I can combine these two middle terms and make that just 1I on 3. My last term has an I squared, which is really -1. I have that -2, so it's going to be a +2 on 3, which means now I can add those two. So 6 on 3 plus 2 on 3 is 8 on 3 plus I on 3. All right, and there it is. That was pretty good. Last slide here. The last thing we're going to do with them is we're going to solve equations that have imaginary solutions. So like this first one, I would move the 9 over. Now we get x equals square root of, x equals negative, x squared is, I can't talk. X squared is -9. Take the square root of both sides. Don't forget your plus or minus, and you see what I'm talking about. We have a negative inside there. So take the I out, take the square root, you get plus or minus 3I. Second one doesn't factor because there's no factors of I that give you 4 as long as the I is positive. So I'm gonna complete the square here. I'm gonna say x squared plus 4x. I'm gonna move the 5 to the other side, leave some space. All right, now remember, half the middle, square it, add to both sides. So I'm gonna take half of 4, which is 2, square it, add it to both sides. Over here on this right-hand side, I get -1. Markers moving the screen everywhere. And the left-hand side, you can now factor. Remember that whatever the half was goes inside your parentheses. Now you got 2 steps to finish. You got to get rid of the square, and you got to get rid of the 2. So I'm going to square root both sides first. If I square root the left-hand side, it's x plus 2. If I square root the right-hand side, guys, that's what I is. I is the square root of -1. So I'm just going to put plus or minus I, because that's the definition of I right there. So move the 2 over, make it -2 plus or minus I. There you go. There's your 2 solutions, and they're complex. All right, so hope that helps. Should be a big review for you guys. You've seen every bit of this before. It's been a long time, since your algebra 2. So anyway, we'll work on it tomorrow. See you then.